Hello everyone, welcome back to my YouTube channel. This is Shubham, as you know. Today we'll be discussing permutation questions. And if you want to go through the theory behind all these things, permutation and combination, all the different cases of different types of questions and scenarios, then do visit the previous videos. I have explained in detail all the theories. Do check them out, and I'll put the link of those videos in the description as well. So now this is specifically to additional math and international math, that is 0580 IGCSE and 0606. So yeah, let's begin. So all these questions are from basically permutations. So let's go ahead with the first question over here. It says a shelf contains 7 math books and 3 geography books. So what is the interpretation from here? We are given with 7 math books and we are given with 3 geography books. All right. Now it says, in how many different ways can they be arranged if? So here the keyword is arranged. That means it's a question of permutation. Okay. If there are no restrictions. So the first one. So we have total 7 plus 3, which is 10 distinct objects. Why is it 10 distinct objects? Because all the math books and all the 3 geography books will be different. So this can be arranged in 10 factorial ways. Make sense? Perfect. Now, second one. In how many different ways can they be arranged if they are grouped by subject? So that means they're talking about, let me highlight it. All these 7 math books, they are one group, and all these 3 geography books, this is also one group. So total 2 groups are there, which can be arranged in 2 ways, 2 factorial ways. And then these 7 math books can be arranged, right, in 7 factorial ways among themselves. And similarly, applying the same logic, these 3 geography books can themselves be arranged in 3 factorial ways. Are you following? So that's the answer for the B bit. Now, coming on to the C1, it says only math books need to be grouped together. So that means, what is the concept here? This is one group and the remaining 3 geography books. So all the 3 geography books, I could write it as G1, G2, G3. So 3 different objects plus 1, this entire group is 4. So total 4 objects are there, which can be arranged in 4 factorial ways, multiplied by these 7 math books can themselves be arranged in 7 factorial ways. So 4 factorial multiplied by 7 factorial. And you can compute these values using the calculator, obviously. That will be your answer. All right, perfect. Now let's move on to the second question. As you can see over here, let's read this. So it says a shelf contains 5 Thai books and 4 Japanese books. Okay, so let me write this. 5 Thai books, I'm writing it as short form TB, and 4 Japanese cookbooks are there. In how many different ways can they be arranged if there are no restrictions? Okay, so as we know that all these, Thai books, cookbooks basically, they are different, and all these 4 Japanese books are also different. And therefore, answer for the first one, 4 plus 1, 4 plus 5, which is basically 9. So that can be arranged in 9 factorial different ways. Okay, arranged means permutation. So 9p9, actually I should write here 9p9. Okay, which is nothing but 9 factorial over 9 minus 9 factorial. Okay, and you can also apply the concept of this n factorial. N factorial simply means n distinct objects which can be arranged in a line. Okay, in how many ways? So that is n factorial. Now next thing is they're grouped by category. So let's analyze this one. Grouped by category means what? This is one category, and 4 Japanese cookbook is another category. So we have, again, 2 groups which can be arranged in 2 ways, multiplied by all these Thai cookbooks can themselves be arranged in 5 factorial ways, multiplied by, and these Japanese cookbooks can themselves be arranged in 4 factorial ways. So I'm saying again, right? And so again and again, it's a continuous process. When something is in continuous process, we use and therefore we need to multiply all of this. Fine, perfect. Moving on to the C1. The first cookbook is Thai and the last one is Japanese. Okay, so first book is this and the last book. So put dashes here. So 2 books, right? So in how many ways can I, select, or you can arrange the first place with 5 given Thai cookbooks? So this can be arranged in 5 ways, because each and every Thai book is basically different, right? Similarly, the last which has to be, the last one is Japanese. So these are conditions basically. Now, how many Japanese cookbooks are there? There are total 4. So this can be filled in 4 ways. So now one book is already here and one Japanese book is already filled over here, right? So in the middle, how many are left? Left are how many? So left are total were how much? 5 plus 4, 9. So left are 7. So they can be arranged in 7 factorial ways. So final answer 5 times 4 times 7 factorial. Okay, because 2 books are already taken in the beginning and in the last. So 9 minus total was 9 minus 2, which is basically 7. And since these 7 are distinct, so they can be arranged in 7 factorial ways. Okay, so that's your answer for this. Perfect. I hope the question is clear. Okay. Now moving on to the third one. Third question is, how many different 3-digit numbers can be formed from the digits 1, 2, 3, 4, 5 if no digit is repeated? Okay, so this condition is given. Repetition is not allowed. And then coming on to the first one, it says, how many of the 3-digit numbers found in part A are less than 300? Okay. So basically, how many 3-digit numbers can be formed, right? So let me just solve this part itself. So isn't it just 5 factorial? Right. So five digit means what? 1, 2, 3, 4, 5. This can be filled in 5 ways because repetition is not allowed. 4, 3, 2, and 1. Right. So these are continuous. First this and this and this, then this and this, which is nothing but basically 5 factorial. Okay. Now moving on to the first question. How many of the 3-digit numbers found in part A are less than 300? So this itself is part A. Less than 300 means what? So again, 1, 2, 3. Okay. So this was 5 factorial for 5 different digits, right? So they had asked here less than 300, a 3-digit number I need to find, isn't it? So 3-digit number, how it will look like? 3 dashes you'll put. Now this can be filled in 5 ways, this can be filled in 4 ways, and this can be filled in 3 ways because the repetition is not allowed. So I'll just multiply, which is basically 5 over 20 times 3, which is 60. So total numbers is 60. Okay, this is the total. Right? So 3-digit numbers found in part A are less than 300. Less than 300 means what? The first place I could fill it by either 1 or I could have 2. Right? So this can be filled in how many ways? The first place, it can be filled in 2 ways. Right? Now, if one number is fixed, which is already taken in the first place, how many are left now? 4. So the second place can be filled in 4 ways multiplied by, now here one is filled and here one is filled. So remaining numbers are 3. So this can be filled in 3 ways. Got it? So 4 times 2 is 8 times 3 is 24. So 24 numbers are there, 3-digit numbers, which are less than 300. Got it? Perfect. Now let's move on to the B part. How many of the 3-digit numbers found in part A are multiples of 5? So 3-digit number, multiples of 5 means what? Here we have the choices 1, 2, 3, 4, 5. And in order to have, the number to be a multiple of 5, the unit digit should be 5. So can I say I have to fix 5? We have fixed this. And there is only one way to put this 5. Are you getting it? Now I have to think these first two places can be filled in how many ways? This can be filled in 4 ways and this can be filled in 3 ways. Okay, so this 5 is only 1, which is just 1 way. All right, so final answer 4 into 3 into 1, which is nothing but basically 12. Getting it? So there are 12 numbers which are multiples of basically 5. Okay, I hope it makes sense. Now moving on to the next one, the C bit. How many of the 3-digit numbers found in part A are multiples of 5 less than 300? Okay, so less than 300 means what? Again, constraint, it's a multiple of 5, so 5 is fixed over here. Now, this number should be less than 300, right? So when it will be less than 300, when I have here in the 1000 place, in the 100 place, either 1 or 2. So this can be filled in 2 ways, right? Either 1 or 2, isn't it? 5 is already fixed. So 1 is already taken over here. 1 digit has gone over here. Now out of 5, 3 are left. So this can be filled in 3 ways. Okay, so final answer 2 into 3 into 1, because 5 is fixed and you can fix 5 only one way. So this becomes 6, 2 times 3 times. Because the 100 place can only be 1 and 2, it should be less than 300 and also a multiple of 5. Okay, then once 2 digits are done, because repetition is not allowed over here. Okay, I hope it makes sense. If repetition was allowed, then 2 into 4 we would have done. Okay, or 2 into 5, because 5 can also be repeated. 5 is also a multiple of 5, but then it will be greater than 300. So you have to keep all these things in mind. Now moving on to the next concept question. So let me get this. How many different 5-digit numbers can be formed from the digits 1, 2, 3, 4, 5, 6, 7, 8, 9 if no digit is repeated? Okay, repetition is not allowed. Fine, and 9 digits are there. How many of 5-digit numbers, okay, are even? So let me answer the first bit. Put 5 dashes, 1, 2, 3, 4, 5. Even, right? So we know that when a number is even, when the unit digit is either 2 or 4 or 6 or 8, isn't it? These are the only possibilities we have. So this can be filled in 4 ways, right? And repetition is not allowed. So here now we can fill this starting from the left. Always have a habit of filling from the left, right? This way it will be easy to do. So one digit is already done. Now out of 9, how many are left? 8. This can be filled in 8 ways, and then the second place in 7 ways, 6 ways, and 5 ways. So you just multiply this. 8 times 7 times 6 times 5 times 4. And that's your answer. So you have to do this in the calculator. Okay. Don't just leave till here. Use calculator to solve it. I'm just teaching you the concept. So this way, once you have to find the answer, you will practice it on your own also. Okay. Perfect. Now the next thing is, how many of the 5-digit numbers found in part A are greater than 40,000? Okay, so greater than 40,000 means 1, 2, 3, 4. Greater than 40,000 means the leftmost digit, right? It should either be 5 or 6 or 7 or 8 or 9, right? So I can fill the first digit over here from the left in 5 ways, in 5 different ways. Now, since repetition is not allowed, how many digits are left if one digit is used in the first place? Out of 9, total 7 digits are left. So this can be filled in 7 ways, and then this can be filled in 6 ways, 5 ways, and then 4 ways. So final answer is 5 times 7 times 6 times 5 times 4. This process is also called as basic principle of counting. Okay, does that make sense? Perfect. Moving on to the next one. We have, let me use a different color here. A shelf contains 5 mathematics books. Okay, 5 math books, 3 science books, and 2 physics books, right? So this data we have, and the total is how much? Always mention the total. 5 plus 3, total 10 books are there. Okay, this is given to us. In how many different ways can they be arranged? Arranged means what? Permutation. Okay, so let's answer the first bit. There are no restrictions. So 10 different things are there, and they have to be arranged in a line in 10 different ways, right? So that can be done in 10 factorial ways. That's the answer. Coming on to B bit, they're grouped by subject. Okay, so let's understand that. Grouped by subject. So this is one group. 3 science textbooks, this is one group. And 2 physics books, this is one group. So total 3 different groups I have. So this can be arranged in 3 factorial ways. Okay, multiplied by, since every book is different, yes or no? Every book is different. So 5 math books can themselves be arranged in 5 factorial ways. 3 science books can themselves be arranged in 3 factorial ways. And 2 physics books can themselves be arranged in 2 factorial ways. So that's your answer. Okay. Now coming on to the C1, there is a physics book at each end. Okay. So let's fix them. So in how many ways can I keep the first place with physics books? There are 2. So the first place could be filled by 2 ways. And then once one physics book is placed in the first place, there is only one way to fill the last. Getting it? So the first place can be filled in 2 ways. Okay. So first and last, there are two places and two physics books are only there. Two physics books. Okay, so that can be done in two ways, multiplied by one way, because one physics book is already kept in first place. So only one is there and one place. So one factor. Now the remaining over here are how many? Eight, right? So eight different books are there. So that can be filled in 8 factorial ways, right? So your final answer is 2 into 8 factorial. Getting this concept? So 2 into 8 factorial. So do this in the calculator and write the final answer. I hope you're getting it, because each and every textbook is different. So total, since two books are already used over here, remaining 8 places are there and 8 different objects which can be arranged in 8 factorials. Getting it? Okay. Now, moving on to the next one. It says in a group of, tourists, 5 are Chinese, 4 are Asians, and 3 are Europeans. They are asked to stand in a straight line before they enter an exhibition. In how many different ways can the line be arranged if, so again a permutation question, all the Chinese tourists stand together? Okay, so A, all the Chinese, they stand together. That means this is one group together, right? So 4 plus 3, 7, 7 plus 1, total 8. So they can be arranged in 8 different. So 4 plus 3 is 7, 7 plus 1 group is 8. 8 different objects can be arranged in 8 factorial ways, multiplied by 5 Chinese can themselves be arranged in 5 factorial ways. So that's the answer for the first one. Okay, I hope you're getting this. Next, all the Asian tourists and basically they stand together, and all the European tourists stand together. Okay, so all the Asians, all of the Asian are standing together. Okay, and what else? All of the, so 4 are there, so this is one group, and all of the Europeans. Okay, Europeans are 3 basically, so this also becomes one unit, isn't it? Now how many are left? 5 Chinese are left. So 5 Chinese plus these two groups is basically 7, right? 5 plus 1 is basically 7. So they can be arranged in 7 factorial ways, multiplied by 4 Asians can themselves be arranged in 4 factorial ways, multiplied by 3 Europeans can themselves be arranged in 3 factorial ways. Getting it? So they have said here Asian tourists stand together and all the European tourists stand together. So this is one group, and all the 5 Chinese people are different, isn't it? That's what we have discussed. If at all you find this difficult and you want to go through the theory, do visit my previous videos, whose link I have put it in the description, so you can check it out. Okay, so the detailed theory I have discussed over there. Now coming on to the C, the first in the line is European and the last in the line is also European. Okay, so put 2 dashes. First person can be filled in 3 ways, because 3 Europeans are there and either of them could take the first place. Now once one European is done, for the last to be European, how many are left? 2. So this can be filled in 2 ways. Now remaining over here, now and is there, isn't it? So I'll multiply, because first this will be filled, then this will be filled. So now 2 Europeans are done. Now how many are left out of, the total is 12. 2 are done, so 10, isn't it? So 10 are left. So they themselves can be arranged in 10 factorial ways. So 3 times 2 times 10 factorial. That is the answer. I hope you're getting this. Okay, because Europeans are done, 2 Europeans are done. So 3 minus 2 was 1. So 4 plus 1, 5, 5 plus 5. So 4 Asians, 1 European, and 5 Chinese. All these 10 people are different. They themselves can be arranged in 10 factorial ways. Okay, I hope it makes sense. Perfect. Now coming on to the last question for this concept, let's discuss what it is. It says I have a bag containing 12 numbers. So total is 12 numbered balls. 12 balls are there. Okay. 3 of the balls show the number 3. Okay. 4 of the balls, they show the number as 4. Okay. Next 5 of the balls, they show the number as 5. Right. So that means when I'm talking about these balls, they are identical over here, because all the 3 balls are showing 3 as a number. And therefore, this is the case of identical, right? So repetition is there. They're repeating, right? Common stuff. Now, what is the question here? 5 of the balls show the number 5. Okay. I take out one ball at a time and place it on the table to form a row. Okay. So to form a row, how many different arrangements? That means it's a question of permutation. Are there if I use all the 12 balls? Okay. So to answer the first one, 12 objects are there that can be arranged in 12 factorial ways. Numerator will not change. And then you divide by the common things. So 3 balls are there which have 3 numbers. 4 balls are there which have 4 number, and 5 balls are there which have 5. Okay, so divided by the common balls. This is common. Numerator will remain as it is, and then denominator you divide the commonalities. Okay. Coming on to B. So the B says how many different arrangements are there in which the same numbers are grouped together. So same numbers are grouped together means what? 3 is grouped together, that's one group. 4 is grouped together, that's one group. And 5 is grouped together, that's one group. So total basically there are 3 groups, right? So these 3 groups are different among themselves, isn't it? So this can be arranged in three factorial ways. As a group, they are different, isn't it? As an individual, these 4 are identical. These 5 balls are identical. Similarly, 3 balls are identical. Now, they themselves can be arranged in 3 factorial ways. 4 balls can themselves be arranged in 4 factorial ways multiplied by 5 factorial ways because individually they can be arranged in these ways. Divided by what are common. 3 balls are identical, 4 balls are identical. So we just divide by the common elements. So as you can see, these 3, 4, 5, 3, 4, 5 cancels out. You only get 3 factorial, which is 6, right? So 6 arrangements are possible. So I hope, friends, you've got a basic idea of this. We'll discuss more challenging problems and past problems in the next video. So stay tuned and do share my video with your friends so that they'll be benefited with this quality content. Thanks for watching.